Swayam Prabha. Digital India. Educated India.
Okay, we come across the introduction about that unit 4 regarding that regression, and we spoke about the model set data and data set related to regression. Let us go to discuss the fundamental idea about the regression, and based on that we will go to the further theory about the machine learning and AI. So, regression. When the random variable x and y are linearly correlated, the points plotted on the scattered diagram corresponding to n pairs of observed values of x and y will have tendency to cluster around a straight line. This straight line is called a regression. So, this regression line can be taken as the best fitting straight line for the observed pairs of the values of x and y in the least square sense with which the students are familiar. So, when two random variables x and y are linearly correlated and we may not know which variable takes independent values, if we treat x as an independent variable and assume that the values of y depends on those of x, so the regression line is called as regression line of y on x. If we assume that the values of x depends on the linearly independent variable y, so the regression line x on y is obtained. So, thus in situation where the distinction cannot be made between the random variable x and y, to which is the independent variable and which is a dependent variable, and there will be two regression lines. However, when the value of y of x to be predicted corresponding to specified value of x of y, we should make use of the regression line y of x on x of y. So, equation of regression line of y on x. So, regression line y on x is the best fitting straight line for the observed pairs x1 y1, x2 y2 and so on xn yn, based on the assumption that x is an independent variable and y is a dependent variable. Hence, let the equation of the regression line y on x be assumed as y equal to ax plus b. By the principle of least square, the normal equation which gives the values of a and b are collect all the y summation y equal to a into summation xi plus nb, where n is a number of observation, and summation xi into yi equal to a into summation xi square plus b into summation xi, call it as 2 and 3 respectively, and divide equation 2 by n. Therefore, it becomes what summation yi by n, summation xi by n. We have what summation yi by n is a mean y bar, summation xi by n is called as x bar is a mean, and n and gets we have a b. So, that is equation 4. Now, x bar is ex and y bar is ey. Therefore, 1 to 4 gives the required equation, that is y bar y minus y bar equal to a into x minus x bar. So, eliminating b between 2 and 3, we have a equal to summation xi yi minus summation xi into summation yi by n into summation xi square minus summation x the whole square, xi the whole square. So, we can write a divide throughout by n in the numerator, therefore 1 by n to summation xi yi, and here is summation xi yi by n and summation yi by n, divide throughout by n square in the numerator, denominator also n square. So, that summation xi square by n minus 1 by n to summation xi. So, the meaning of this one is expectation of x comma y, the meaning of this one is expectation of x and this is expectation of y by summation x into e into x square and summation e square into x, which is equal to rho of x comma xy and sigma of x square. So, that is the equation 6. Using 6 in 5, we get the equation of the regression line of y on x as y minus y bar equal to rho into xy by sigma x square into x minus x bar. Therefore, y minus y bar equal to rho of xy equal to r of xy into sigma y by sigma x into x minus x bar. So, we have r of xy equal to rho xy by sigma x sigma y. In a similar manner, assuming the equation of regression line of x and y as x equal to ay plus b and using the equation summation xi equal to a sigma y plus nb and summation xy ya equal to a into summation y square plus b into summation y, we get the equation of the regression line of x on y as x minus x bar equal to rho into xy by sigma y square into y minus y bar, or x minus x bar equal to r into xy into sigma x by sigma y of y minus y bar. So, we have a note rho of xy by sigma x square or r xy sigma y by sigma x is called regression coefficient of y on x and is denoted by b1 or byx. Rho xy by sigma y square or r xy sigma x by sigma y is called a regression coefficient of x on y and denoted by b2 or bxy. So, clearly the product of b1 b2 equal to r square into sigma xy, that is r xy is a geometric mean of b1 and b2. Therefore, r xy equal to plus or minus root of b1 b2. The sign of r xy is same as that of b1 or b2, as b1 equal to r xy into sigma y by sigma x and b2 equal to r xy into sigma y by sigma x have the same sign as r xy. Since sigma x and sigma y are positive, also b1 by b2 equal to sigma y square by sigma x square. So, when there is a perfect linear correlation between x and y, namely when r xy equal to plus or minus 1, so the two regression lines coincide. So, the point of intersection of two regression line is clearly the point whose coordinates are x bar comma y bar. When there is no linear correlation between x and y, namely when r xy equal to 0, so the equation of regression line becomes y equal to y bar and x equal to x bar, which are at right angles. So, the standard error of estimation of y, although we use the regression line of y on x to predict the value of y corresponding to specified value of x. So, we may also use it to estimate the value of y corresponding to observed value of x equal to xi. So, the value of y estimated in this manner need not in general be equal to corresponding observed value of y, namely yi. Hence, the difference between the y and ye is called error of estimate of y. This error will vary from one observed value to the other and a random variable. So, the standard deviation of RV of y minus ye is called standard error of estimate of y and denoted by Sy. Now, expectation of y minus ye equal to expectation of y minus of y bar plus rxy sigma y by sigma x into x minus x bar. So, which is equal to y minus y bar minus r into xy into sigma y by sigma x into x minus x bar, and this is equivalent to one another, therefore, it becomes 0. Now, sigma square of y minus ye equal to expectation of y minus ye the whole square minus e square of y minus ye. So, which is equal to e into y minus y bar plus rxy sigma y by sigma x into x minus x bar the whole square. Therefore, expectation of y minus y bar square plus rx square into sigma y square by sigma x square into x minus x bar the whole square minus 2 rxy sigma y by sigma x into x minus x bar into y minus y bar. So, that is s square y equal to sigma y square plus rxy square into sigma y square by sigma x square into sigma x square minus 2 rxy into sigma y by sigma x into covariance of x comma y. So, which is equal to sigma y square. So, these two get cancelled, therefore, r square xy into sigma y square, and this becomes what 2 into r square xy into sigma y square, convert rxy into sigma y by sigma x and get cancel sigma x sigma y square, because covariance of x comma y equal to rxy into sigma x sigma y. So, which implies 1 minus r xy square into sigma square y or sy is equal to root of 1 minus r xy square into sigma y. And similarly, the standard error of estimate of x denoted by Sx is given by Sx square equal to 1 minus r xy square into sigma x square, or Sx equal to root of 1 minus r square xy into sigma x. So, we have a note, we may use 1 or 2 to prove that modulus of rxy is 1 less than or equal to 1. So, from 1 sy equal to root of 1 minus rx square into sigma y. Since sy and sigma y are positive, therefore, 1 minus r square xy is greater than or equal to 0. Therefore, r square xy is less than or equal to 1, implies modulus of rxy is less than or equal to 1, or minus 1 less than or equal to rxy less than or equal to 1. So, the maximum of R rank correlation with respect to x and y is minus 1 to 1. Now, based on this, we have to start the problem. Obtain the equation of the line of regression from the following: x equal to 1, 2, 3, 4, 5, 6, 7 and y equal to 9, 8, 10, 12, 11, 13, 14. Now, given data x, you write it 1 to 7 and corresponding y is 9 to 14. 9, 8, 10, 11, 12, 11, 13, 14. Now you have to take average of x is 4. So you have to take x minus 4. So first column minus 4 we have third column, right. So minus 3, minus 2, minus 1, 0, 1, 2, 3, and second column and subtract with 11 because 11 is a mean. So v equal to y minus 11. So subtract with y second with minus 1 minus 11, that is add with minus 11. So 9 minus 11 is minus 2, minus 3, minus 1, 1, 0, 2, 3. Sum them become 0 for u as well as v is 0, and then fifth column is square of the second column. So, square of the first column, sorry, square of the third column. So, which is equal to third column square. Therefore, minus 3 the whole square is 9, minus 2 the whole square is 4, minus 1 the whole square is 1, 0, 1, 4, 9, add them. So, add them, we have 28, and similarly for v square is that is sixth column is equal to fourth column square. Therefore, minus 2 the whole square is 4, minus 3 the whole square is 9, minus 1 the whole square is 1, 1 square is 1, 0 square is 0, 2 square is 4, 3 square is 9, and seventh column is a multiple of fifth and sixth, fifth into sixth. So, uv calculate it. Now, uv calculated, therefore, third into third column into fourth column, therefore, minus 3 into minus 2 is 6, minus 2 into minus 3 is 6, 1, 0, 0, 4, 9, add them 26 will come. Therefore, x bar equal to E of x. E of x is nothing but that is x bar. Here mean is 4, and then number of observation here is totally 7. Therefore, 1 by 7 into summation of u 0. Therefore, net value is 4. Here this becomes 0 and this becomes 7. Similarly, E of y equal to the mean is 11, summation v is 0, and here is 7, therefore 11 will come. Sigma x standard deviation with respect to x square is equal to summation u square by n minus 1 by n to summation u, and n equal to 7, therefore 1 by 7 summation u u square, summation u square is 28 by 7, and summation u is 0 here, therefore 28 by 7 is 4, and sigma y square is summation 1 by n summation v square of 1 by n summation v the whole square. Summation v square is 28 by 7, here this one is 0, this one is 7, for 28 by 7 equal to 4. Therefore, C of xy, the correlation covariance of xy equal to 1 by n to summation uv minus of 1 by n to summation u into 1 by n to summation v, which is equal to summation uv is 26 and n is 7, therefore 26 by n 7, and u is 0, summation v is 0, therefore 26 by 7 is 3.7. Now, the regression line of y on x is y minus y bar equal to rho into xy by sigma x square into x minus x bar. Therefore, y minus 11 equal to 3.7 by 4 into x minus 4. Therefore, 3.7x minus 4y plus 29.2 equal to 0 is a regression line y on x. Now, we are going to calculate a regression line of x on y is x minus x bar equal to rho into xy by sigma x square equal to y minus y bar. So, x minus 4 equal to 3.7 by 4 into y minus 11. So, which is equal to simplify cross multiply 4x minus 16 equal to 3.7 into y minus 11. Therefore, 4x minus 3.y equal to what? 3.7 into 11 minus 16 plus 16. So, 24.7 equal to 0. So, this is the regression line of x on y. Now, we have another problem. Obtain the equation of the regression line from the following data using a method of least square. Hence, find the coefficient of correlation between the x and y. Estimate the value of 1 y when x equal to 38 and 2 x when y equal to 18. So, the data is x equal to 22, 26, 29, 30, 31, 31, 34, 35 is given. Therefore, we have to put it in the column x, y equal to 20, 20, 21, 29, 27, 24, 30, 27, 31, put it in the column y. Now, this is the first column, second column, third column to be determined with the help of the average value is 29 mean. Therefore, u equal to x minus 29. So, 3 equal to 1 minus 29 equal to minus 7, that is 22 minus 29 is minus 7. Next one is minus 3, 0, 1, 2, 2, 5, 6 will come. Therefore, 3 equal to 1 minus 29, and similarly for fourth column the mean is 27. Therefore, v equal to y minus 27. Therefore, second column minus 27 is minus 7, minus 7, minus 6, 2, 0, minus 3, 0, 4, and add them, minus 17 will come. You got third and fourth. Fifth column is third square equal to 3 square, and sixth column is what? Fourth square. Therefore, a third square is what? 49. 49 and 3 minus 3 square 9, 0, 1, 4, 4, 25, 36. Next sixth column is 49, 49, 36, 4, 0, 9, 0, 16, and uv equal to 49, 21, 0, 2, 0, minus 6, 0, 24 equal to 90. So, using the relevant value from the table 2 and 3, we have 6a plus 8b equal to minus 17 and 128a plus 6b equal to 90. Call it as 2 and 3, solve them. You have the value of a equal to 0.83 and b equal to minus 2.75. Hence, the regression line of y on x is y minus 27 equal to 0.83 into x minus 29 minus 2.75, that is y equal to 0.83x plus 0.18. So, the equation of regression line of x on y be x equal to cy plus d, or equivalently u equal to cv plus d. So, the normal equation of finding c and d are c into summation v plus nd equal to summation u, and c into summation v square plus d into summation v equal to summation uv. So, using the relevant values from the table in 6 and 7, we have minus 17c plus 8d equal to 6, and 1063c minus 17d equal to 90, and solving 6 and 7 we get c equal to 0.81, d equal to 2.47. Hence, the regression line of x on y is x minus 29 equal to 0.81 into y minus 27 plus 2.47, and simplify x equal to 0.81y plus 9.60, that is the equation 8. So, this is x on y, we substituted in equation 5 and got it 8. Now, comparing equation 4 with y minus y bar equal to r into sigma y by sigma x into x minus x bar. Now, we get r into sigma y by sigma x is 0.83, because we calculated sigma y and sigma x here. Okay, sigma x is calculated here, and then comparing equation 8 with x minus x bar equal to r into sigma x sigma y into y minus y bar. So, 8th equation is here. So, this is the 0.881, and r into sigma x by sigma y is 0.81, and this one is compared with the equation 4. 4 is 0.83 of r into sigma y by sigma x and sigma x by sigma y equal to 0.81. Now, you got 9 and 10, multiply them, r into sigma y by sigma x into r into sigma x by sigma y. So, get cancel, we have r square. So, r square equal to 0.83 into 0.81, therefore, r equal to 0.82. Since B1 equal to r into sigma y by sigma x and B2 is r into sigma x by sigma y are both positive, and we use the equation 4 to estimate the value of y when x equal to 38. Therefore, we got what x 38 and substitute in 4. So, this is the 4th equation, and x equal to 38, substitute it. So, we have y equal to 0.83 into 38 plus 0.18 equal to 31.72, and using equation 8 to estimate the value of x when y equal to 18. So, we have x equal to 0.81 into 18 plus 9.60 equal to 24.18. So, we got x as well as y. Next, a study of prices of rice at Chennai and Madurai gave the following data. The Chennai corresponding mean is 19.5, the Chennai corresponding standard deviation is 1.75, Madurai is 17.75 and 2.5. Also, the coefficient of correlation between the two is 0.8. Estimate the most likely price of rice 1 at Chennai corresponding to the price of 18 at Madurai, 2 at Madurai corresponding to price of 17 at Chennai. Solution: let the prices of rice at Chennai and Madurai be denoted by x and y respectively. From the data, x bar equal to 19.5, y bar equal to 17.75. and sigma x equal to 1.75, sigma y equal to 2.5 and rxy equal to 0.8. So, the regression line of x on y is x minus x bar equal to r into sigma x by sigma y into y minus y bar. Here x bar is 19.5, y bar is 17.75 and sigma x is 1.75, sigma y is 2.5 and r equal to xy is 0.8. Now, substitute in the equation x minus 19.5 equal to 0.8 into 1.75 by 2.5 into y minus 17.75. So, when y equal to 18, then x equal to 19.5 plus 0.8 into 1.75 by 2.5 into 0.25, which is equal to 19.64. So, the regression line of y on x is y minus y bar equal to r into sigma y by sigma x into x minus x bar. So, y minus 17.75 equal to 0.8 into 2.5 by 1.75 into x minus 19.5. When x equal to 17, then y equal to 17.75 plus 0.8 into 2.5 by 1.75 into minus 2.5 equal to 14.89. Next example, in a partially destroyed laboratory record of an analysis of the correlation data, the following results only are legible. The variance of x equal to 1, the regression equations are 3x plus 2i equal to 26 and 6x plus y equal to 31. What were number 1 the mean values of x and y, what were number 2 the standard deviation of y, what were the correlation coefficient between x and y of the question 3rd. Solution: since the lines of regression intersect at x bar y bar, so we have 3x bar plus 2y bar equal to 26 and 6x bar plus y bar equal to 31. Solving these equation, we get x bar equal to 4 and y bar equal to 7. So, which of the two equation is the regression equation of y on x? Which one is a regression equation x on y are not known. So, let us tentatively assume that the first equation is a regression line of x on y and the second equation is a regression line of y on x. So, based on this assumption, the first equation can be rewritten as x equal to minus 2 by 3 y plus 26 by 3. So, the second equation written as y equal to minus 6 x plus 31. From 1 and 2, from 1 we have minus 2 by 3 is bxy. From 2 we have byx equal to minus 6. Now, we know that directly finding the r square of xy is bxy into byx. So, which is equal to minus 2 by 3 into minus 6. So, we have what minus 4. So, minus 4 here minus and minus plus 4. Therefore, r square equal to 4. So, r equal to plus or minus 2. Minus 2 is absurd. So, our tentative assumption is wrong. So, the first equation is a regression line y on x rewritten as y equal to minus 3 by 2 into x plus 13 and second equation regression line of x on y and rewritten as x equal to minus 1 by 6 into y plus 31 by 6, right, rewritten as. So, the correct byx equal to minus 3 by 2 and the correct bxy equal to minus 1 by 6. Now, r square xy equal to byx into bxy equal to 1 by 4. Therefore, r xy equal to minus half. Therefore, both byx and bxy are negative. Now, sigma y square by sigma x square equal to byx by bxy equal to minus 3 by 2 by minus 1 by 6 equal to 9. Therefore, sigma y square equal to 9 into sigma x square equal to 9. Therefore, sigma y equal to 3. Another example, given that x equal to 4x plus 4y plus x and y equal to kx plus 4 are regression lines of x on y and y on x respectively, show that the k values lies between 0 to 1 by 4. If k equal to 1 by 16, find the means of x and y and rxy. From the given equation, we note that byx equal to k and bxy equal to 4. From this, r square xy is bxy into byx equal to 4k. Now, rxy is lies between 0 to 1. So, definitely 0 is less than or equal to 4k less than or equal to 1. From this, divide 4 on both sides, therefore 0 less than or equal to k less than or equal to 1 by 4. So, when k equal to 1 by 16, then r square xy equal to 1 by 4. Therefore, rxy equal to plus or minus 1 by 2. But both byx and bxy are positive. Therefore, rxy equal to half. When k equal to 1 by 16, so the regression equation becomes x equal to 4y plus 5 and y equal to 1 by 16 x plus 4. So, solving equation 1 and 2, we get x equal to 28 and y equal to 5.75, that is the mean is 28 and mean of y is 5.75. So, this is they asked and r of xy asked, that is also found out. Next example, find the angle between the two lines of regression. Deduce the condition for the two lines to be at right angles and number 2 coincident. So, the equation of the regression line is y minus y bar equal to r into sigma y by sigma x into x minus x bar, or x on y is x minus x bar equal to r into sigma x by sigma y into y minus y bar. Therefore, the slope of line 1 is r into sigma y by sigma x is m1, for 2 is sigma y by r into sigma x is m2. Say, so angle between the two lines tan theta equal to modulus of m1 minus m2 by 1 plus m1 m2. Therefore, m1 is r sigma y by sigma x and m2 is sigma y by r into sigma x by 1 plus sigma y square by sigma x square. From the first step, sigma y by sigma x, take it outside, so that r minus 1 by r into sigma x sigma y will come by take LCM sigma x square plus sigma y square by sigma x square, sigma x square get cancelled. Therefore, cross product r 1 minus r square by modulus of r equal to sigma x by sigma y by sigma x square plus sigma y square. So, this is the meaning of theta. right. In terms of M1, M2 we written like this. So, the two regression lines at angle theta equal to pi by 2 when tan theta equal to infinity, therefore, R equal to 0. When the linear correlation between x and y is 0, the two lines of regression will be at right angles. So, the two regression lines are coincident when theta equal to 0, that is when tan theta equal to 0, R equal to plus or minus 1. Therefore, when the correlation between x and y is a perfect, therefore, the two regression lines will be coincide. Now, we have example for any two random variable x and y with the same mean. So, the two regression equations are y equal to ax plus b and x equal to cy plus d. Find the common mean ratio of the standard deviation and also show that b by d equal to 1 minus a by 1 minus c. The solution is mu is common mean. So, the point is mu comma mu lies on the y equal to ax plus b and x equal to cy plus d. So, the intersect at x bar comma y bar is mu equal to a mu plus b. Therefore, mu plus c mu plus d, which is equal to from 1 mu equal to, from 1 we have mu equal to b by a 1 minus a, from 2 mu equal to d by 1 minus c, and equation 3 and 4 are equal. Therefore, LHS equal to RHS. Therefore, b minus 1 by a equal to d by 1 minus c, and cross multiply b by d equal to 1 minus a by 1 minus c, and we know sigma y square by sigma x square equal to byx by bxy, which is equal to a by c. Therefore, sigma y by sigma x equal to root of a by c. So, find the standard error of the estimation of y on x and x on y from the following data: x equal to 1, 2, 3, 4, 5 and y equal to 2, 5, 9, 13, 14. Now, we have x value, y value. So, x is 1 to 5 is given, y is 2, 5, 9, 13, 14 given, and x square do that, y square do that. Simply square of x first column, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, add them, summation will come. Similarly, you take the second column, so square them, fourth column will come, 2 square 4, 5 square 25, 9 square 81, 13 square 169, 14 square 196, and add them, summation 475 will come, and first column into second column we have a 2, 10, 27, 52, 70, which is equal to 161. So, the regression x on y equal to n into summation xy minus summation x into summation y by root of n into summation x square minus of summation x the whole square into n into summation y square minus summation of y the whole square. You know number of data is 5, therefore, n equal to 5, and xy is equal to what? Summation xy equal to 161 and summation x is given 15, summation y is 43 is given, substitute it. Similarly, you have to substitute the denominator. So, after simplification numerator 160 will come, denominator is root 50 into 526 equal to 0.9866, and we have to find the standard deviation with respect to x, sigma x square equal to 1 by n to summation x square minus 1 by n to summation x whole square. So, we have 1 by 5 into 55 minus of 1 by 5 into 15 the whole square equal to 2. Therefore, sigma x equal to 1 minus 4142, the standard with respect to x. Sigma y square you have to calculate 1 by n to summation y square equal to minus of 1 by n summation y the whole square. After substituting the value of summation y square and summation y, we have 21.04. Therefore, sigma y equal to 4.5869. Therefore, Sy equal to root of 1 minus Rxy square into sigma y, which is equal to root of 1 minus 0.9866 the whole square into 4.5869, which is equal to 0.7484. Therefore, Sx equal to root of 1 minus Rx square into sigma x, which is equal to 0.2307. So, that is the required value of x and y.